first heard about this program, my first thought was, we can do this. Like, this is, people in this room are open source program office managers in large private sector companies, key developers who understand big data. You already heard about the blockchain initiative. I mean, this is what we do. I think the important thing, and really the call to action for all of you is, this is a big deal. Climate change is one of the most important issues facing mankind. And what you just heard is that all of the skills that all of you have, whether it's how to manage an open source project, how to work in big data, everything we've already heard today can actually have an impact. And after the Paris Accords, which we talked about this before the Paris Accords, but after the Paris Accords, the clock is ticking. Governments all over the globe have made a commitment to this, and we need a system now that will hold them to those commitments. So that's just how big a deal this is. So I really would like you to not only come talk to this effort, talk to me, we'll hook you up with the right people, talk to your bosses, get your company committed to this. This is a very important effort. Thanks so much. Thanks so much, Jim. All right, well, our next speaker is going to talk to us about a darker side of the internet, and perhaps one where there's tremendous opportunity, but there's also tremendous risk. Martin Mickos, I think, needs very little introduction in this crowd. He is a good friend of mine. He was the CEO of MySQL. He but couldn't be outdone. He went and started Eucalyptus Systems. That was later acquired by HP, where he headed their cloud business. And again, not to be contained, Martin then said, I've got to start I've got to go work and be the CEO of yet another company, and has landed at HackerOne. HackerOne is a really interesting company that is a leading vulnerability coordination company and is best known for their bug bounty platform. And Martin Mickos is going to talk to us today about, once again, how to make the internet a more secure space. Come on up, Martin. We also kept Martin from skiing today, so this is a very big honor.
Thank you, Jim. Thank you. How hard do I need to click?
Really hard.
Really hard. Hi, everybody. It's all about security now, but unfortunately, security is malnutrition and poorly served, and there's an $80 billion market for security products that are not doing their job. And it's not anymore the dark side, it's becoming the light side, because security is becoming a very positive part of what we do here. And I'm certainly here to repay some old security debt, because back in the 90s when Linus started with Linux, he didn't think about security. And when MySQL started in 1995, we didn't think about security. We just built an easy-to-use, fast, robust database. Because on the internet you had just fun things that were not that serious. Today, however, the internet and the connected society is winning, and everything that's vital in society is running in a connected system. So the exposure is much, much larger. And now with every system and everything being connected, the risk is even bigger. So people like me, we have to go back and clean up what we created before and create some security and turn it into a positive trade. It doesn't have to be snake oil. It doesn't have to be just adhering to compliance and doing cover your ass. There's a lot of positive measures you can take in security that make your systems and your building blocks secure. Oh, this. Okay, I sent an updated slide deck. This is not the updated one. This will be a faster talk. That's fine. I will speak to the other slides. But this is one of my slides, absolutely. I recognize it. I was going to tell you that what I'm doing. For the past 15 years, I've been building business models that empower developers and hackers, and really empower them. Because for some reason, I believe in hackers, although I'm not a hacker myself. And I want to empower them to meet really difficult challenges, to do the right thing, and to be properly paid for it. And that's what I did as CEO of MySQL, then at Sun Microsystems, CEO of Eucalyptus, then head of the cloud business at HP, and now CEO of HackerOne, where we have a community of thousands and thousands of hackers in the world who hack your systems at your request, and you pay them a bounty when they do a good job. And customers include General Motors, Uber, Twitter, the Tor project, and so on. So that's what we do here today. And we came into this industry thinking that the security industry is fundamentally flawed. The world is spending $80 billion a year buying all kinds of hardware and software products that solve some part of security but still don't provide enough protection. And we've had for a decade or two thinking that humans are really weak and have all kinds of flaws, and the solution to this is more technology. Just throw more firewalls on your system and it will work. And now finally we are realizing that maybe it's the other way around. Tech is the problem and humans are the solution. If we have well-defined problems, then machinery is good at finding them. Robots and software and scanners, all of those can find well-defined problems. But guess what? Our problem today, security, is not well-defined. It is very ill-defined. It's very difficult to know where the problems are. And we have black swans, the unexpected bugs. And the most creative way of finding them is using human beings. So it turns out that tech is the problem, but human beings is the solution. And as all of us know in this room, there are lots of human beings in this world, and you don't have to stop at just those who work for your company. You can invite and work with people from all over the planet. We have 7 billion people here on the planet, and soon everybody will know how to code, and everybody can be a hacker, and everybody can find flaws and fix them. Yeah, you really have to click. Another mistaken paradigm was the whole thing about secrecy around security. In the traditional security space, there's always secrecy. You keep your flaws secret, you keep your problems secret, you keep your people secret, you don't tell anybody about the problems you have. That's completely wrong. And mankind has known for a long, long time. Go back to Kirchhoff's principle from 150 years ago, where he said the design of a system should not require secrecy. Or then you take the NIST 800-123 definition, where they say the same thing, that the design of a system and the security of a system must not depend on secrecy of the components or their implementations. Keys can be secret, but the implementation needs to be open for us to reach full security. And this, again, I realize I'm preaching to the choir, but many of you represent companies where they're still thinking that whenever there's a vulnerability, whenever there's a bug, you need to keep it secret. But it is in openness that security truly happens. This is also why the Linux Foundation is one of the best equipped organizations to deal with this, because the Linux Foundation was built on openness from the foundation, and everything they do is open. And we've now seen that that is the best way to build full security into systems. And of course, full security doesn't exist. As long as human beings are creating systems or creating robots that create systems, we will have flaws and bugs and vulnerabilities. That's inevitable. And it's interesting that what I'm learning now at HackerOne, that we talk about vulnerabilities, it's more than just bugs. You can get the vulnerability from a configuration parameter, from how you deploy, from how you use it, from how you define the processes. So it's not just a strict definition of a software bug. There are many other things. There can be software without any bugs that still is vulnerable because there's some vulnerability in how it is being deployed, for instance. Security is also achieved in collaboration. You all have clearance to work on cybersecurity. We all have clearance to do that. Millions and millions of people in this world can help work on cybersecurity. But again, in the classical world, we talk about special teams, red teams, teams with clearance, and we think that security is best achieved by small teams. Sure, you may need a small team, but you don't know who you need. But when you go outside of your own organization and collaborate with others, you'll find the expert who can help you exactly with what you need to do. And when you collaborate broadly, you get into this stochastic power of crowdsourcing and the wisdom of the crowds, that an ill-defined problem will find its solution, because the crowd out there is so uncontrollable that they will test everything, they'll try everything, they'll do everything, and sooner or later they'll find the bug that no test team could find, no scanner, no pen testing, no QA team, because it was so weird that it took sort of an external person without much internal knowledge to find it. And when we talk about collaboration, we must always remember that collaboration is not about all of us agreeing. On the contrary, the power of the open source movement is that we collaborate even when we disagree. And I haven't seen many communities that disagree more than open source. Well, now I have, the security world. But the power of good governance of collaboration is that you can collaborate even when you disagree, and you have a method for resolving the conflicts, and that's how it works. So it's not dependent on goodwill, it's not dependent on altruism by anybody. Everybody is acting for their own interest. Everybody might disagree with everybody else, but stuff still gets done. And it's the same thing in security, which we're seeing now. And you could say that what happened to software in the past 20 years is now happening to the security space. It's opening up, it's becoming more collaborative and much more powerful. So whatever principles we follow in security, there's an easy way to destroy security. That's to be slow. Today the world is connected, and whatever there is out there that's vulnerable, you have to act fast. You have to be an agile organization that can fix the bugs quickly. And not only fix the bugs quickly, first you must identify them quickly. So quickly go out there and ask the community help you find them. Then you need to fix them quickly, and in all of this you need to communicate with your hackers, security researchers, finders, whatever you call them, very quickly, because they are impatient people. And if you don't respond to them quickly enough, they lose interest and go somewhere else, and you miss the value that they are bringing. And the difference between one single hacker paying attention to your system or not could be the difference between security and an enormous breach where you lose personal information, privacy, money, operational readiness of a production system or something. So it's very important to act fast. And of course the adversary here, whoever it is with malicious intent, is learning to be faster and faster and faster. And us who are on the defense side, we have to become faster and faster and faster, fix these things quicker so that they can't be exploited for malicious intent. And we saw that with Heartbleed, we've seen it with really serious problems that we have in the open source community that we now need to fix. That's what I mean by the security debt that we are carrying. Back in the 90s and 2000s, we were like open source hippies. Everything was fun, everything was allowed, everybody could participate. And now we need to be responsible open source citizens and build security into the whole framework of software development. So security needs to be part of the software development life cycle from the very beginning. And I'm a sinner here, so I'm admitting that I didn't think like this until some years ago. But the only way to build truly secure systems, and like I said, there's not 100% secure systems, but truly secure ones, is to start from the beginning. In the software design, in architecture, in how computer scientists are trained, security needs to be an everyday part of their work. It has to be the essence of what they do from the very start. And I think that's happening now in our educational systems, and the new developers and hackers I see grow up, they have that. They take it for granted and they think about security from the very start. But that is the only way to build systems that are resilient. And you have to do it at every stage. It's cheapest in the beginning, but then you do it all the way to the end. And at the end, when you have your system in full production use in the connected society on the internet, then you run a bug bounty program that will be the ultimate post-mortem analysis of whatever you did in the software development lifecycle. Because you do want the ethical hackers, the white hat hackers, to find the flaws before the criminals find them. With that, I had one more slide. I'll talk to summarize my beliefs on security. Is number one, we need to be open about security, and we need to learn to take openness from just the source code being open to APIs being open and to vulnerability coordination being open. We have to be open about all of those things. That's the most powerful method of creating resilient software and resilient systems. Number two, we must collaborate on this because nobody is strong enough to do all of this themselves. We have the Linux Foundation with the CII initiative, which is very important for this. HackerOne is running a program called the Internet Bug Bounty, where we pro bono collect vulnerability reports and organize them for open source software projects. There are other organizations, CERT and others, who help there, but we need to work together. And thirdly, we need to embrace security as an integral part of software development and make sure that it's there from the very beginning, when we train our people, when we design our software, when we code it, when we test it. And that's how we build a connected society that is not so dramatically vulnerable as our society happens to be today. So with that, thank you. I'll give you 6 minutes back.
Wait, I want to ask you a couple questions. So when we went out to breakfast the other day, one of the things that we talked about is, Linus Torvalds and I had a conversation about security, and one of his comments was, and I like how you characterize it as a debt, and I don't want to place a debt on the kernel community either, but he said, one of the things about developers often is they're not able to think like a security researcher. They're not able to think like a hacker when they're writing code. And I'm telling this to Martin, he's like, I know where those people live. That's my new job. So it's just terrific to see the work you guys are doing, and the Internet Bug Bounty program is just an amazing program. So if you don't know HackerOne, I love the idea that humans are the solution to this problem.
I just spoke to a 15-year-old boy in northern Pakistan who had helped Coinbase fix a bug, and I think that's just so powerful on all dimensions.
Yeah, and again, and it ties into this idea of that big umbrella. Like, it's not just, hardcore developers who are making code, but where can we find that Pakistani kid to come in and help with this? So thanks so much for everything you guys are doing.
Thank you.
Appreciate it.
Thanks.
Our next speaker has been working on open source projects in another industry that has been changed dramatically by open source. In fact, it's changing dramatically through a transformation from a traditionally hardware-dominated industry to an industry that is being essentially software abstracted or becoming software-defined. Dave Ward is the CTO and Chief Architect at Cisco Systems. I really am a big fan of Dave, mainly because he's a Minnesota guy, where I also grew up, as you heard earlier. And he is going to come talk to us about some really exciting happenings in the networking sector and how open source is really changing that area and how we can do even better. So welcome, Dave Ward from Cisco. Come on up.
Thanks, Jim. So Jim actually didn't know what I was going to talk about because I sent him nothing. So that was a great intro, but I'm actually going to talk about something really different than that. So I'd actually, I want to take the spirit of the Collaboration Summit and talk about a lot of what we saw today. We saw lightning talks starting at the top of the stack with Cloud Foundry, going through Cloud Native, and then going through just a whole slew of networking stuff. And you might wonder how this all hangs together. How is this going to actually work? And that's what I want to talk about today. So I'm not going to pitch a particular project, although I love a lot of the projects that I work in. But instead, let's pop this up a level and talk about where we're going inside the Linux Foundation between application developers and networking. Next slide, please. Interesting. This is 2 meetings in a row in which, excellent, perfect. So the target here, I just want to orient everybody. The very top in the PaaS layer, those are the conversations Chris had about Cloud Foundry and what's going on up there. And you saw this really interesting set of modules of ways to orchestrate containers, hypervisors, workflows, etc. We then brought in, again, a bunch of networking folks that talked about their SDN controllers and how these different projects could be brought together like OPNFV into services and orchestration. Remember, SDN and NFV that was discussed earlier today has focused almost exclusively on the services orchestration piece, and to make a point in conversation for today, almost all of SDN has focused on this one arrow of what is my favorite protocol to program the network. Interesting, necessary conversation, but not sufficient really to move things forward and make it all work. Recently, the Fast Data project just came up in the Linux Foundation with a technology called Vector Packet Processing along with DPDK. And so we now have industry class virtualized networking for L2, IPv4, V6, MPLS, segment routing, all your favorite endcaps, QoS, large tables it can handle. And just to summarize, on a pedestrian 4-socket computer with 64 cores, with only 24 of those cores, you can fling 480 gigs worth of V4, V6 with ACLs, MPLS, doesn't matter. Network, check. We've got it inside the Linux Foundation. But what's interesting is there's an entire half of this piece that hasn't been addressed. And that's, how did my workflow perform? How did that service chain for network function virtualization actually perform? And although we had a little bit of a conversation about analytics today, this is a massive part that's missing for developers and for the community. And we'll talk about this a bit more as well during this talk. Next slide, please. So I'm legally required, as with a word architect in my title, to show you a stack diagram. And so this is that stack diagram. And what I want to show you is that this is also a diagram of the history that the industry has walked through on its conversation about how to program the network and how to build stacks. Originally, SDN was all about, can I please just automate my physical topology? We then connected VLANs back in the day to create virtual topologies. We then realized that, wait, we actually want to be able to spin up load balancers and firewalls and other toolbars. In the middle of that, that becomes the service that's to be delivered. We then realized that, wait a minute, these workflows, whether NFV or applications, are actually a topology that needs to be, and I'm a networking guy, so I think a topology is a topology of apps and services that need to be deployed together. But if we pop all the way back to that first talk on Cloud Foundry, that line that I drew is everything that was below Cloud Foundry. And all of the modules they had were everything that they enabled to allow applications to be built. And from that developer point of view, I want to fire up my workload and I just want it to work. And so a notion in the industry of there will be whole stack developers, I'm putting forward that there really are no human beings on the planet that can understand every one of those connection points and how this comes together. And in fact, trying to work towards a set of developers or a community that could understand that may be a too challenging proposition. And a couple of other things. So underneath the line, I want to head towards a no-stack world. Infrastructure, network, compute, storage, please do what I want. Please do what I need. And the other thing I wanted to call out that, again, being a networking guy, that's really frustrating for me, is that today somebody can fire up and ask for CPU, RAM, and storage, but they can't even ask for bandwidth. They can even have very, very simple networking primitives all the way up to the PaaS layer. Next slide, please. So below that line, and part of its complexity now just put into text, all of these different functions written in these boxes are what that orchestration and infrastructure and SDN stack has to be able to do to be able to maintain and run a service or workload or workflow inside a data center or cloud and across the network. stuff is complex. There's a reason why the networking industry might be late bloomers, or I might be a late bloomer, Jim, I'm not sure, but why this stuff is actually really quite hard. But rounded to the nearest integer, I'm not sure developers way up at the PaaS layer or using Node.js really care, or in fact really want to know. And so my goal in working in open source and working towards building these different projects and the stack is to enable them such that they don't have to know and don't have to care, which is a very, very strange thing for maybe for an industry guy to stand up and say, but that would be my ultimate goal. The infrastructure will just do what a developer needs to have happen. Next slide, please. So I'm not going to round out and talk about all the foundations. I already mentioned fastdata.io. It's a rock and roll bit-banging forwarding plane that the industry's needed. But instead, I want to talk about going up the other side of that chain to analytics. Next slide, please. And that's really towards the analytics. If you guys could push me forward one. So, as I'm waiting for that to happen, I'll try this too. No? So the next slide really is talking about the data analytics platform that we need so desperately in the industry. So I want to give somebody could hit page down on that computer, or a space bar, or a down arrow. Imagine, if you will, the next slide actually has a notion of a midstream project called Platform for Network Data Analytics. And where the networking industry is now going is not only are there programmatic interfaces for programming and configuring and provisioning the network itself, we've now entered the 1980s, and instead of pulling and querying all resources that are in a data center and a network, we're pushing them out. We're doing a push instead of a pull. This actually might take that OSS, not the open source, but the actual operation system and billing system problem that Jim mentioned, and move it into the current era, where there is a scale-out platform of a lot of common open source projects. Logstash on the bottom for syslogs. There's a whole bunch of stuff for IPFix or NetFlow, and a whole bunch of other connectors that can actually be built and have been built underneath, say, Spark. Pick your favorite database, as these are fairly modular for both Elasticsearch as well as real-time analytics. Push it really hard. Okay, so here's where I am. Basically, analytics is a CF, and I don't mean Cloud Foundry. What I mean is that if you're actually trying to do OSS, you're trying to understand how your workflow actually worked. You're actually trying to answer these questions of fault, performance, resource, etc. And they're a set of variables that are actually available in those resources. And so that architecture can emerge as a midstream project, but in this particular case, I've been talking with Jim about creating this instead of yet another foundation around this. Instead, can we try a different way of collaborating as an industry on this half of the wheel, and creating a sponsored project to create this midstream project around a scale-out data analytics platform. So what this turns into as an industry is really, we have on one side the orchestration, configuration, provisioning going into the resources, using a variety of mechanisms to orchestrate hypervisors, containers, or in a hybrid data center across the network, streaming that data out of the network into the platform for network data analytics, and creating a large reactive set of infrastructure and orchestration underneath the PaaS layers. And the reason why I say this is, going back to that original wheel, the way that we have currently had the conversation, the industry, is around SDN controllers as a platform, analytics platforms, writing apps directly on the network, when in fact there will be applications that work at that particular layer and those particular elements and controllers for a straight IT point of view. But I think the action is really above that line towards creating applications, NFV, all the way up at the PaaS layer, and creating a no-stack developer environment in which intent can be driven directly into the network. And so what that means is directly enabled out of that PaaS layer could be the services that are available either via NFV or from those resources directly available to provide new services directly out of that cloud. And what that also means is that we can directly create a new community and new communities in an entirely new industry based at that layer and providing direct revenue and value directly out of that layer, because it's just not available to developers today. Load balancers, firewalls, NATs are about the state of the art of the industry of what you can call up out of that layer, and you actually have no understanding of how that workflow actually ran. And so if you're following me with this argument, and this does become the target of how we would like to see and collaborate among the many projects we have inside the Linux Foundation, let me just show you how one way this kind of fits together. So as we know, over the last 2 years, networking folks showed up in a big way in open source, and it's been a fantastic thing for the industry to not arguing over documents and standards bodies, but instead just collaborating on code. And so a bunch of those projects. The slide that Jim stole from me several months ago, I'm calling you out. And I'm also going to call out that if you take a look at my stack and you actually recall back to his, Jim got it wrong, but it's okay, he's executive director. It's your show, Jim, you got it right. Really falls into a set of projects that actually build on top of each other in that basic layered architecture. The Linux Foundation has done an outstandingly good job in putting together and pulling together communities that fill certain niches and certain functionality inside this stack, and have placed multiple bets. And placing multiple bets and actually having some overlapping functionality in different communities, I think, is a very good thing. There is nothing concrete. If we knew what we were doing, we probably would have done it already as an industry, but this is exactly what open source is for. So this umbrella concept, as a networking guy, the networking community has come into open source, and it's a lot of the same companies, and it's a lot of the same people who are doing the coding. There's a lot of us, there's a lot of people coding, there's a lot of people participating, but it's been a little bit like kiddie soccer, where here's the new shiny object, let's all go there, and we all show up in the same place, we show up in another place, and perhaps we need an umbrella because there is actually not rain but sunshine with the amount of resources and people and communities that are emerging on this particular piece. I think that time is actually now, and we should have that conversation. Not only about do we want to build towards this architecture and how do we want to evolve the communities that we have, but as a networking community in particular, do we want to evolve how we have governance so we can most effectively resource and work towards a common architecture. Linux Foundation has proven itself to be a perfect place for us to collaborate. It's been an outstanding experience. The industry's really come together, and Jim, you and the crew have done a great job. So we have the right projects. I think this is the right time, and I think it's worth a conversation over the next couple of days, and this is really what I'm trying to catalyze through this talk, a conversation about how to take all the projects we have and pull them together under an umbrella. So let me just continue to walk you through on how this has gone. In early 2015 or so, here was the set of projects and roughly what the stack looked like that we were working on with Jim, and there is a dramatic difference between, if you agree with me on what we need in that reactive wheel for developers and for the community. We're missing a lot of pieces in early 15, but it was an outstandingly good start. When we take a look as we go through 15 and 16, and there's up to 8, depends on how you count, how you look at it, new projects that suddenly arrived into the industry. I'm also worried that we're going to have a bit of success failure, that there is so much going on that we're actually not accomplishing what we need to as a community, and this is an outstandingly large number of people who are contributing just not only millions of lines of code, but hundreds and thousands of hours of their time towards this effort. And when we look at what's going to be happening minimally of some of the things that I know about inside the industry, there are some really critical projects that are coming. We heard about the Open Container Initiative We need something like that for VNFs, or virtualized network functions, or virtualized services, that actually describes what they are and what's necessary for them. And right now that's housed in the Armory project inside Open Daylight, but it's actually a critical piece of the overall stack infrastructure for someone to be able to deploy a workflow inside a data center. And then Panda is something that the platform for network data analytics that we just talked about, that is absolutely critical. It's critical to know not only what happened or what's going on inside the data center or inside the network, what's going on inside at the different layers, from the resources to physical to virtual to service to policy, etc., but also how did my workflow and how did that service perform? And that's that key piece. So the fundamental desires, I think, of certainly the folks that I work with, and I think about some of the products that we have. For example, WebEx, the world's largest enterprise SaaS application that's deployed on the internet today, is built on Cloud Foundry and built on a lot of these pieces. And their desires have changed. And as we build cloud DVRs, we build a whole bunch of products on top of all of this open source technology, we're looking to be able to fill out that wheel and understand exactly how to create a reactive networking service to what's going on inside the network and inside those resources. So